This is the first video about today's lesson, which is completing the square and the quadratic formula. And we're going to begin by introducing an area model. So we have three different tiles here. Um, and there's two things that you should notice about each of these. Number one, they have dimensions, a base and a height. This is a square. Its height is x, and its base is x. So its area is x squared. This tile has a height also equal to x. This length right here is the same as this length right here. So that makes it x, and then it has a width of 1. So its area is 1x. And then this last little tile has a length of 1 and a height of 1. And you might notice that this length, which is also 1, is the same as the base and height of this little rectangle. So we can actually construct any quadratic expression with a collection of these tiles. That is, any quadratic that has integer coefficients and positive terms, which is all we're going to be working on right now for the moment. And so this quadratic, x squared plus 5x plus 6, is represented by one of these x squared tiles and these 5 single x tiles, and then these 6 units. And maybe you already noticed that this quadratic can be factored, just x plus 3 times x plus 2. And we'll see that on the next slide. But if you can factor a quadratic, that means that you can also take these tiles and rearrange them into a big rectangle. And that's what I did here. I divided up these 5 x's on these two sides of the x squared tile. And then I did it in such a way so that I could fit all 6 of those single tiles right here in the corner. So I made a perfect rectangle here, and I can measure the sides of this rectangle. This is x right here, that length, and then each of these is 1. So the side of the big rectangle here is x plus 3, and similarly, the side of uh, this side of the rectangle is x plus 2. And as you know, this is an area model, so the sum of the areas of each of these individual tiles, I could represent with this expression, and that should be equal to the product of the base times the height, which is this expression. And you already know about factoring, so you can see that these two expressions are equivalent. The purpose of this is really just to introduce this area model. And just before I go to the next slide, I want you to notice that this x squared always appears in the top left-hand side, and these single units always appear in the bottom right, and then the x's are always divided up between these two corners here. So I call this a generic rectangle. So rather than drawing every single little tile, I can just represent this really colorful rectangle in uh, this more simple rectangle. And like I said, I call that the generic rectangle. Same information though. Here's my x squared. These are my 3 x's and my 2 x's, and then my 6's are down here in the corner. And you should see that each of the elements on the outside multiply to make the area uh, that I've labeled on the inside. So here are 3 quadratics, and you should take a moment now, just pause this video, and see if you can draw the rectangle that represents each of these 3 quadratics. This last one is a little bit challenging, but just remember, all of your rectangles should look like this. So go ahead and pause the video and do that right away. Okay, now that you're finished with that, I wanted to just make a special note of this quadratic right here in the middle. And here's the rectangle in all of its colors. And just notice that this is called a perfect square because when you can actually divide these six x's evenly, three of them down here and three of them over here. You divide those evenly, and uh, the 9 units fit nicely into this corner. And what we have here is a very special rectangle. It's a square. And a square is a special case of a rectangle. And it has dimensions x plus 3 by x plus 3. So the area of this big rectangle is x plus 3 squared. And we call that a perfect square. So that's a pattern that we're going to use throughout the next few videos um, in order to do what we call completing the square. So take a look at the next video to start understanding how to complete the square.